All right, hey guys, so we are going to finish up lesson 6.5. Let me present my other screen. Okay, so our goal today is to talk about the change of base formula, which I mentioned back in like 2 or 3 videos again. I mentioned it. It was in your notes, but we actually didn't use it. We could have, I just chose not to, but we're going to talk about it here. Okay, so logarithms in any base can be rewritten in terms of common or natural logarithms using the change of base formula. Okay, so I mentioned in the last video or one of the videos ago that if we only had a scientific calculator, scientific calculators don't have the ability to put in your own base, right? So when I pull up my calculator, I can go to math and I have the ability to put in whatever base value I want. Okay. But scientific calculators just have this log button here where the base is already 10, right? It's a common base. Common base is 10. Okay. And same thing with ln. It has an ln button, but the ln base is e. So we want to know, well, if we didn't have our fancy calculators, how could we rewrite a problem in terms of the common or natural logarithms? Okay, so the change of base formula is this. If we have log base c of a, it's equal to log base 10 of a divided by log base 10 of c. So we say it's log of the big number over log of the small number. And I don't mean in value, I mean like physical size, right? So log of a, because that's always like the bigger number, and then c, because it's a small little subnotation number. So log of big number over log of small number. And I'll even write that. You might want to write that in your notes as well. So it's log of big number over log of, we'll say small, or if you want to say base number. Okay. And also, if we have log base c of a, you can write it as the natural log of a divided by the natural log of c. And still, it's going to be the big number over the base number. Okay, so an example, if you have log base 2 of 3, you can write that as log, it's base 10 of 3 divided by log base 10 of 2. All right, if you have log base 16 of 32, that's going to be base 10 of 32 over log 16, which is base 10. Okay, so let me scroll up. Evaluate using the change of base formula. All right, so we can evaluate this by converting it into log 11 over log 7. Okay, and we're going to use our calculator now. So if you grab your calculator, all right, you're going to, let me get my cursor. Okay, so get a fraction, alpha y equals, and get your fraction up in the numerator. We're just using the common log. So log 11, close it, and then log of 7. And then we'll push enter to get our evaluation. And to prove to you that that is the same, I'm also going to type in the original problem. So if I type in log base 7 of 11, it should evaluate to the same thing. Log base 7 of 11 is the same evaluation. Okay, so we'll say that it's approximately 1.23. All right, so using the change of base formula, how would you rewrite this one? Okay, we'd rewrite it as log of 19 over log of 2. Or if we want to use the natural log, just because we didn't do this for the last problem, we could also say it's natural log 19 over the natural log of 2. And I'll show that they're all the same approximations, all 3 of them. Okay, so on my calculator, I'll do the original problem first. Let me erase this over here. Okay, so the original problem was log base 2. So math, log base 2 of 19 All right. Now I'll use the change of base formula. So alpha y equals common log 19 over, I should close that parenthesis. It would still work. I just like to close the parenthesis. Okay, and push enter. And now let's use the natural log. So alpha y equals, to get a fraction, the natural log of 19 over the natural log of 2. All right, so you get the same approximation all 3 times. You get approximately 4.25, 4.25, 4.25. Okay. All right, so that's your change of base formula. Next, it says solve by graphing. Okay, so there are steps we can kind of follow for solving by graphing that I'll write out before we do the problem. So your steps. First, you're going to set equal to 0 if it's not already equal to 0. Okay, if it's already set equal to 0, move to step 2, which is try to factor if you cannot factor, use quadratic formula to find zeros. All right, and then third, use test points to determine working zones. Okay, so it's already set equal to 0. I'm going to try to factor, which luckily is factors, so we don't have to do the quadratic formula. Okay, so we have x times x will give you x squared. 7 times 4 will give you a negative, or give you 28. It'll be negative if one of the values of is negative. If I have a negative 7 and a positive 4, that'll add to negative 3, but multiply to negative 28. Okay, and then I can say that x minus 7 is less than 0, x plus 4 is less than 0. So I have x is less than 7, and x is less than negative 4. All right, so then I'm going to plot negative 4, 0, and 7. Okay, you're going to use the points to determine working zones. So pretty much I have to test 0, or a number, I should say a number between negative 4 and 7. You want to test a value between negative 4 and 7. 0 is always an easy one to test. Then you want to test the number to the left of negative 4. So maybe you test like negative 7. And then you test a value to the right of 7. So maybe you test like 10. You pick a number and you see which ones work. Okay. So you're going to test, we'll test negative 7. We'll test 0. And then over here, we're going to have to test 10. Again, you can pick any numbers you want. You just have to pick a number between the 2 zeros, a number to the right of one of the zeros, and to the left of the other 0. So when I say test negative 7, that means plug it in to see if it works. So if I have negative 7 minus 7, negative 7 plus 4, is that less than 0? Well, negative 7 minus 7, that's negative 14. Negative 7 plus 4, that's going to, I'm sorry. Let me plug back in. I should always plug back into the original. I wasn't. I looked up here. Let's plug back into the original. Otherwise, my work's not going to match my answer key anyway. So it should be negative 7 squared minus 3 times negative 7 minus 28 is less than 0. Okay, so now I have 49, and then that's going to be a positive 21 minus 28 is less than 0. Okay, and when you check, does that simplify? 49 plus 21 minus 28, is that less than 0? No. Okay, it's going to be greater than 0. So that does not work. All right, so then I'm going to test 0. So I have 0 squared minus 3 times 0 minus 28. Is that less than 0? Well, 0 squared is 0. Minus 3 times 0 is 0. So this all turns into just a 0. So I have negative 28 is less than 0. That does work. All right, so I know that 0, this region works. And then testing 10, so I have 10 squared minus 3 times 10 minus 28, is that less than 0? So that's going to be 100 minus 30 minus 28. Okay, if you have 100 and you subtract away 30, all right, what are you left with? 70. And then if you take 70 and subtract 28, okay, are you going to have less than 0? No, that does not work. So 10, which was to the right of 7, did not work. Negative 4, which was to the left of negative 7, which was to the left of negative 4, did not work. But 0, which was between 4 and 7, did work. So that means you're going to have open circles on negative 4 and 7, and we shade in between. Okay. All right. So that's a reminder of how to do those graphing problems. Let's keep on moving. All right. So here it says solve by graphing. We're going to use a graphing calculator to do these. So what you're going to do is, since you have on both the right and left side, you have quadratics, you're going to make y sub 1, like the left-hand side of the equation, 3x squared minus 2x minus 5. And then you're going to make y sub 2, x plus 2 squared plus 1. Okay. And you're going to use graphing calculator to graph the two functions. Okay. And then, well, let's do that first, then we'll talk about what we should do next. All right. So let me grab my calculator. All right. So I'm going to go to y equals, clear out the functions I have. So I have 3x squared minus 2x minus 5. Okay, that's your first equation. My second equation is x plus 2, that quantity squared, squared, get out of it, and then plus 1. Okay. So you can see you have two parabolas. All right. And when you're asked to solve, what you're going to be looking for is the points of intersection. Okay. And the x values are important. They're the answer. And I'll kind of talk about why in just a second. Why not the y's as well? But anytime you have a system, you're looking for the points of intersection. So after you come up with your graphs on your calculator, you're going to calculate intersection points. Point or points. There may be one, there may be more than one. All right, so how do you do that on the graphing calculator? Well, you're going to hit second, and then right above trace, it says calculate. Second, calculate, and then you're going to go down to intersect. Number 5. Okay. It says first curve. So as long as you're on one of the functions, the blue is fine. I'm going to kind of get close to where they intersect. I'm going to push enter. And then it's going to say second curve. So as long as you're on the other parabola, this time I'm on my red parabola. Again, just stay close. It doesn't really matter where you are, but as long as you're close to the intersection and you're on that second curve, that second parabola, push enter. And then it's going to say guess, and you push enter a third time. It's going to land right on the intersection point. All right, and you're going to write the coordinate down just for now, and then we'll talk about the answers in a second. So the intersection, one of the intersection points is negative 1.19, comma, and we're obviously rounding, 1.65. Does it look like the parabola probably intersects again? It does. All right, so it looks like it probably intersects up higher. Now you can change the window You could zoom. It's kind of up to you. I'm going to change the window. Let's change the Y maximum. Let's change it to 40. Let's see if that's high enough. All right, so almost. I'm going to change the window again. Let's change it to, let me change it. Why am I not going down? Oh, I'm not on it. You can change it to 100. You can change it. Let's just change it to 80. Okay, so now I can definitely see where they intersect. And I'm going to go through the same process. So second, calculate or trace, go down to number 5. You want to be on the first curve. So as long as you're on one of the parabolas, for me, it's my blue one, and get close to the intersection location, push enter. Then as long as you're on the second parabola, okay, for me, it's my red parabola. Again, stay close to the intersection point, push enter. Push enter a third time for the guess. It should land right on it. And then we can write down the coordinate. The coordinate is 4.1.19 and 39.35. Okay. So I have the intersection points, but the answer for this problem is just the x values. Now, why do you think the answer is just the x values and not the y values? Why don't I want the coordinates, and why do I just want the x values? Look at the original problem. Are there any y values in the original problem? No. Okay, there's only x values. Those are the answers. I put y sub 1 and y sub 2 so that we could use our graphing calculator, but there are no y's in the original equation, original problem. I just want the x values. Those are the answers. So just the x values are the answers. The problem does not have any y values. Okay. All right. So that is really it for this lesson. There are some extra practice problems below. I think there's just 4 quick problems. I'm going to suggest that we do the same thing you did in the last lesson. I suggest that you pause the video and try them on your own and then come back to check. Okay. Because that'll kind of make sure that you understood the lesson for today. So go ahead and pause, take just a few minutes, try these 4, and then come back to check because I'm going to work through them now so that you can know whether or not you got the right answer. Okay. So change of base formula, you'd rewrite this one as log base 10 of 8 divided by log base 10 of 5. And that's going to approximate when you use your calculator to 1.292. The next one, I'm going to rewrite it as log base 9 over, or not base 9, log of 9 over log of 26. Both are base 10. And that's going to be approximately 0.674. The next one I'm going to write as log 14 divided by log 8. And that's going to be approximately 1.269. And then I have log big number 30 divided by log base number or small number 12. And that's going to be approximately 1.369. All right. All right, guys. So that is it for lesson 6.5. And I'll see you back here for lesson 6.6. Bye.